Hi, my name is Rebente Flores and welcome back to my YouTube channel. So for today, we will be discussing application of integration, and it is application of definite integrals specifically, and it is all about the net change in position and distance traveled by a moving body. Before we proceed, the objective of this video is that at the end of the lesson or the video, the learner should be able to use integration or integral to determine an object's direction, displacement, and position. But before we dig into presenting some examples, let us define the terms net change and the following terms as well. So net change, it is the integral of the rate of change. It is also called a displacement or the change in position of an object. Next is we have the term position. It is defined as or it position can be measured in two ways. It could be displacement and the distance. So we have this term distance, which is defined as the total amount of ground covered by an object or the total length of its path, while the displacement is defined as the difference between the starting and the ending position of an object. So this would be the formula we should be familiar, the net change or displacement formula. So we have this FTC here, or the fundamental theorem of calculus. We have this, the integral of the function f of x dt evaluated from a to b is equal to the function of x evaluated from a to b, which is equal to the f of b minus or subtracted by the f of a. So this is the formula we should consider in solving the net change or the displacement of a moving body. So we have this, the integral of v of t dt evaluated from a to b is equal to the integral of s prime of t dt evaluated from a to b, which is equal to the s prime of t minus s of t. So we let t denotes the time and s be equal to s of t, which is the quantity we are measuring as a function of t. The third one is the r of t, or be equal to the s prime of t, which is the rate of change of s with respect to t or time. So the first part of the net change formula is the integral of the velocity, while the second one is the integral of the rate of change of position, and the last one is the displacement or the net change in position. All in all, the total distance traveled over time interval a and b. So we have this given formula here. The integral of the absolute value of b of t dt evaluated from a to b. So we have this given example here as we apply the given formula of the net change. So problem number 1. Water is flowing into a tank at a rate of r of t is equal to t squared cubic feet per minute. How much water flows into the tank over the time interval 1 minute to 5 minutes? First, as we solve the given problem, we should set the or find or locate the given that we can use as we solve um, as we show the solution. So we have this given from the given problem. We let B or the VT be the volume of the tank into be the volume of the water into the tank, then the B prime of T is equal to the R of T, which is we have this given T squared. Remember the formula of the integral of the volume or the velocity integral of velocity. We have the integral of r of t dt evaluated from a to b, and then we all know that the interval here, time interval, as water flows into the tank over this time interval, 1 as the lower limit and 5 minutes as the upper limit. So we just simply substitute or plug those values as of a and b. So we have the integral of t squared, since as you observe here in our given, we have the value of r of t, which is t squared. So we have just simply substitute it also. So we have the integral of t squared dt, and evaluated from the lower limit 1 to the upper limit 5. So we integrate first the t squared, then we came up with t cubed over 3. Is it because in the integration, the power rule, we must consider adding 1 to the power itself and make it our denominator. So we came up with t squared from t, t cubed from t squared over 3. Evaluated from a, which is 1, and b, which is 5. So since we all know that in given interval or the limits of 1 to 5, so we just substitute it to the variable t. So 5 cube over 3 minus 1 cube over 3, and then we just combined since they are the same. Evaluate or simplify. 5 cube is 125, then 1 cube is 1 all over 3, and then subtract 125 minus 1, so we came up with the remaining value of 124 all over 3 cubic feet or feet cube. So the second example is your task. Try to solve the problem number 2. The power used by an appliance is given by P of t is equal to 2 plus sine the quantity of pi t over 12 joule per hour. How much energy is consumed during a 1-day period? So it is 1 day from 0 to 24 hours, since we have 24 hours in a one or in a day. So that would be all. Thank you and God bless.